Hello friends, in this video series of chemical reactions and equations, today we are going to discuss some of the methods of writing chemical reactions. In our last video, we had seen that there are lots of changes going on around us. We classified these changes into two categories, that some are physical changes whereas some are chemical changes. We know that in a chemical change, if changes takes place in a chemical composition of a substance, we call it a chemical change. So we can say that when two substances react with each other and we get a new product which is chemically different, whose structure is chemically different from the initial substance, then we say that a chemical reaction has taken place, and such chemical changes are called chemical reactions. So we can summarize that, or we can say in brief that at the end of a chemical reaction, a new substance is formed. This particular can be understood by this way. Suppose we have a substance A. If it reacts with a substance B and we get a new substance, that is substance C and substance D, and both having chemical composition different from the initial substance A and substance B, then we say that a chemical reaction has taken place. So we can write a chemical reaction in this form. Here we can see that there are two substances on the left hand side of an arrow and there are two substances on the right hand side of the arrow. So left hand side of an arrow and right hand side of an arrow. So left hand side, the substances on the left hand side of an arrow are known as reactants, whereas the substances on the right hand side of the arrow are known as products. Arrow shows the direction of the reaction, that is substance A and B are reacting to give the products, that is substance C and D. Any conditions regarding catalysts, atmosphere, atmospheric pressure, heat, temperature, etc. are written above the arrow. In this way, we can denote a chemical reaction. Now let's understand this phenomena with the help of an example. Suppose we have magnesium. We have done this experiment in our earlier classes. Suppose we have a magnesium ribbon, and if it is burnt in presence of oxygen, you might have seen that it burns with a bright light, and finally we get a substance called magnesium oxide. Now this substance is white powdered in form, and hence we get it as a magnesium oxide. Now this method of writing equation is known as word equation because we have used word instead of the elements, right? Is there any another way or a shorter way to write this equation in shorter form? Yes. You have learned about the symbols, right? So we can represent each elements in the reaction using their symbols. Now what is the symbol of magnesium? We have studied that the symbol of magnesium is Mg. Now magnesium, when reacts with oxygen, symbol of oxygen is O2. When they are heated and in presence of heat, they are converted into magnesium oxide. The symbolic representation of magnesium oxide is MgO. In this way, this is the shorter form of chemical equation. So chemical reaction can also be written using the chemical symbols of the elements present in the reaction. So let's have a look at the changes that are taking place, and before that we are going to study about the number of atoms present in this reaction. Now we have studied earlier that on the left hand side of the arrow we have the reactants and on the right hand side we have the product. Now let us compare the number of atoms on the reactant side as well as on the product side. So here the elements taking part in the reaction are magnesium, that is Mg, and oxygen, that is O. Now magnesium On the reactant side, we can see that there is only one atom of magnesium present on the reactant side. Now the number of atoms on the product side for magnesium is 1. Here also we have only one atom of magnesium on the product side. Similarly, looking at oxygen, we have 2 atoms on the reactant side, that is 2, and on the product side we have only one atom. Means here the number of atoms of elements on the reactant side and on the product side are not balanced. Though Mg has same number of atoms, oxygen doesn't have same number of atoms on both the side, and hence such type of reactions are known as unbalanced chemical equations. So these equations are known as unbalanced chemical equations. Now let us look at the another type of a chemical equation. Suppose there is a reaction between zinc and sulfuric acid. When both this react together, we get a new product, that is zinc sulfate and hydrogen. Now you might have seen, or you may be doing some experiment in which when you take a sulfuric acid in a beaker or a test tube, and if you put some zinc granules in it, you will observe air-like bubbles evolving out of the solution. These air-like bubbles are the release of gas, that is hydrogen. So now this is a word equation. How can we write it in a chemical form? Chemical equation, right? So we are going to use symbols again. Those symbol for zinc is Zn, and that of sulfuric acid is H2SO4. When they both react together, we get ZnSO4, which is a symbolic representation of zinc sulfate, and H2 gas, which is a symbolic representation of hydrogen. Now let us compare the number of atoms on both the sides of the reaction. So number of elements taking place here are zinc, hydrogen, sulfate and oxygen. So total number of elements is 4, which is taking place in the reaction, which is taking part in this reaction. So first of all, let's have a look at zinc. Zinc on the reactant side has one atom, whereas on the product side it has one atom also. Then let's come to hydrogen, that is H2. H2, there are two atoms on the reactant side, and similarly it also has 2 number of atoms on the product side. Now sulfur is represented by S, and it also has only one atom on the reactant side, and similarly we can see that there is only one atom on the product side as well. Now the last element, that is oxygen. Oxygen, we can see that it has 4 atoms on the reactant side, and similarly looking at the product side we get the same number of atoms on the product side for oxygen. So here from the table we can see that both the sides, that is reactant side as well as product side have the same number of atoms for each and every element, and hence this type of equation is known as balanced equation. So here we come to an end of this video. Quickly recall it once again, and we will be looking at the way of or method of balancing the equation, and that is bringing or making the equal number of atoms on both the sides after writing the equation in our next video. So see you till then. Goodbye.